Hello boys and girls, welcome back. Today we're going to kind of be mixing geometry with proportions a little bit, so bear with me. I'm hoping you think this is fun. Alright, so our objective for today, and oops, I forgot to write the word objective, so let's write that right now. Actually, I'm just going to add it in here really fast. Our objective for today is I will be able to find the missing measurement in a scale drawing or scale model. So that's our objective for today. Alright, so some vocabulary that I need you to write down is, first off, scale drawing. So a scale drawing is a proportional 2D drawing of an object. So a lot of times you'll see that when you think of blueprints. Architects make blueprints for a building. Sometimes you make blueprints for a cell when you're talking about cells in science class. Anything that you draw on a two-dimensional of a two-dimensional figure would be a scale drawing. The other side of that would be a scale model, which would be a proportional 3D drawing of an object. So a lot of times we see a globe for the Earth, or once again a cell, a drawing. In this picture, the architects make scale models of buildings when they present it to the board or to the bank when they're trying to get funding for it. So that would be a scale model. Both of them are proportionate. Remember that proportionate means equal. Alright, and then our keyword scale. Scale gives us the ratio that compares the measurements of the drawing or model with the actual measurements. So our scale is our ratio. So here's our example of what a scale might look like. We have 1 inch for 10 miles, or 1 inch is equal to 10 miles. So the 1 inch would be our drawing. So the top number, the first number, is our drawing. This is what, sorry, it's going a little crazy right now. This is what our drawing is going to be, our scale drawing or scale model. So 1 inch on a map is going to represent 10 miles in real life, or the actual, in this case, distance. Maybe it means height, maybe it means depth, whatever the case may be. It's the one that's in real life, or the actual distance. So it's comparing the drawing or the model to the actual distance. So let's take a look at a real life example. So our example is on a map of Florida. The distance between Miami and Key West is about 2.5 centimeters. If 1 centimeter on a map is equal to 50 miles in real life, how far away is Miami from Key West? So these scale drawings or scale models help us when we're talking about something really, really, really big or really, really, really small that we can't draw easily without it being to scale. Alright, so let's take a look at this. So remember that when we're talking about ratios, it needs to be the same numerator denominator, the first one to the bottom. So the distance between Miami and Key West, not that that's really important, but you might need to know, is 2.5 centimeters. If 1 centimeter on the map is equal to 50 miles in real life, how far away is Miami from Key West? So let's take a look at what we know. Well, we know that 1 centimeter on a map is equal to 50 miles in real life. So 1 centimeter on the map is equal to 50 miles. All right, there's our scale. Okay, there's our scale. And we want to know, and we know that it's proportionate, we want to know that if the distance between the two cities is 2.5 centimeters, how far is 50 miles? Or I'm sorry, how far would it be in real life? How far would a miles be? Okay, and remember the labels need to be on the same level. Centimeters, miles, and x miles. We don't know. And now we cross multiply. So we have 1 times x, which is just x, is equal to 50 times 2.5. Alright, so 50 times 2.5 is 125 miles. So the distance between Miami and Key West is 125 miles. That would be a scale drawing. Now let's take a look at a scale model example. They're very, very similar. The liquid outer core of the Earth is 2,300 kilometers thick. A scale model of the layers of the Earth is a scale of 1 inch to 500 kilometers. How thick is the outer liquid core of the model? Alright, so once again, we want to write down what we know. So we know that the outer core is 2,300 kilometers thick, and then we know the scale is 1 inch to 500 kilometers. We want to know how thick the model is. So the scale is 1 inch to 500 kilometers. That's something we know, and we know that it's proportionate or equal to, and we make sure the labels have to be on the same level, so 2,300 kilometers, but we don't know how many inches. That's what we're trying to figure out. So x, we don't know. Cross multiply, 1 times 2,300 is 2,300, is equal to 500x. Now solve for x. Divide both sides by 500. So x is equal to, and that would be 4.6 inches. So on our model, this liquid outer core is going to be 4.6 inches thick. All right, so it's just using our knowledge about proportions and now using it to make a scale. So you try, it's going to be the same scale, same model, but this time instead of the liquid outer core, we're going to be talking about the mantle. So go ahead and pause this video, try to figure this out. And remember that I don't know and I didn't get it and I just didn't do it isn't an acceptable answer. You will need to try this because I just basically gave you all the answers already on this video. Maybe you just need to rewind it and watch it again to try to figure it out. If you have any questions about how I did this or questions about things that we might do in the future, please let me know, and we will be going over the U-Try and anything else, questions that you have when I see you next in class. All right, have a fabulous day. I'll see you later. Bye-bye.